In the depths of dark space, enormous galaxies glimmer with the light of billions of stars, silently gliding through the cosmos. These cosmic giants are among the most impressive structures in the universe. However, behind this magnificent view lies a violent and chaotic reality where galaxies sometimes collide with each other. Today, we'll delve into the fascinating world of these cosmic collisions and explore the galactic mergers known as the deadly dance of stars. Galaxies are vast systems composed of hundreds of billions of stars, planets, gas, and dust clouds. Our Milky Way galaxy is approximately 100,000 light-years in diameter and contains over 200 billion stars. Even comprehending these numbers is challenging. Considering that a light-year is about 9.5 trillion kilometers, it's almost impossible to imagine how vast our galaxy is. Yet the Milky Way is just one of billions of galaxies in the universe. The Hubble Space Telescope's ultra-deep field image shows thousands of galaxies in just a tiny patch of sky. These galaxies come in various shapes, primarily spiral, elliptical, and irregular. Spiral galaxies, like the Milky Way, are recognized by their arms extending outward from the center. These arms contain young, bright stars and dense gas and dust clouds. Elliptical galaxies are more rounded or oval-shaped, generally consisting of older stars. Irregular galaxies lack a distinct shape and are typically smaller, more chaotic systems. Each galaxy type tells its own story and follows its own evolutionary journey. So, how do these enormous structures manage to collide? The answer lies in gravity, one of the universe's most fundamental forces. The laws of gravity, formulated by Isaac Newton in the 17th century and later expanded by Albert Einstein's theory of general relativity, govern the movements of galaxies. Galaxies don't stand still in space, they're constantly in motion and attract each other. This cosmic dance continues for billions of years. Sometimes galaxies pass by each other, but sometimes their orbits intersect, and a collision becomes inevitable. Galactic collisions occur incredibly slowly on human timescales. A complete collision can take hundreds of millions of years. This period is much longer than the entire history of human civilization. However, on an astronomical timescale, this is just a blink of an eye. Considering that the universe is about 13.8 billion years old, a galactic collision is merely a momentary event for the cosmos. When the collision process begins, galaxies start to pull and shape each other. In the initial phase, the outer parts of the galaxies touch, and the distances between stars begin to change. This process resembles a ballet. Two galaxies rotate around each other, forming structures that look like long tails and bridges as they shape each other. The colliding galaxy pair, known as the antennae galaxies, in astronomical history, is a spectacular example of this process. As this process progresses, the structure of the galaxies is dramatically disrupted. Spiral arms unravel, star systems are thrown into new orbits, and the supermassive black holes at the centers of the galaxies are pulled towards each other. In this chaos, something unexpected also happens. Dense gas clouds compress and give birth to new stars. Yes, new life sprouts in the midst of destruction. This is a perfect example of the cyclical nature of the universe. Destruction and creation go hand in hand. One of the most striking effects of galactic collisions is the dramatic increase in star formation rate. Gas clouds that normally exist quietly are compressed by shock waves created by the collision and collapse. This process leads to the birth of young, bright stars. These new stars give the colliding galaxies a blue brightness and cause the formation of new types of galaxies called blue compact dwarfs by astronomers. These intense star-forming regions are also called star factories and represent one of the most exciting stages of galactic evolution. However, the cost of this new life is high. During the collision, many star systems are torn apart or ripped from their galaxies. Some stars are ejected into intergalactic space and embark on an eternally lonely journey. These solitary stars are called intergalactic wanderers and are among the loneliest objects in the universe. Planets can be thrown out of their orbits, and worlds that harbor life can become uninhabitable. This cosmic chaos means destruction for billions of star systems. Yet this destruction also opens the door to new possibilities. Another significant consequence of galactic collisions is the merger of supermassive black holes at the centers of galaxies. These enormous black holes, quietly waiting at the cores of galaxies, are brought together by the collision. Supermassive black holes play a critical role in the evolution of galaxies. They can have masses of millions or even billions of suns and are found at the centers of galaxies. The black hole at the center of the Milky Way, called Sagittarius AI, has a mass of about 4 million suns. The merger of two black holes is one of the most violent events in the universe and causes ripples in the fabric of space-time. These gravitational waves are a phenomenon predicted by Albert Einstein's theory of general relativity and only recently directly observed. The gravitational waves first detected by LIGO, Laser Interferometer Gravitational Wave Observatory, in 2015 originated from the merger of two black holes. This discovery revolutionized the world of physics and astronomy and gave scientists the opportunity to examine hidden aspects of the universe. What about our galaxy? The Milky Way's fate will also be a similar collision. In about 4.5 billion years, we will collide with our neighbor, the Andromeda Galaxy. This event will completely change the appearance of our sky. For billions of years, we'll see Andromeda growing larger in the night sky. When the collision begins, the sky will be illuminated by a spectacular light show. The birth of new stars and the destruction of old star systems will illuminate the sky in an unprecedented way. However, don't worry. The chances of our Earth being harmed by this collision are very low. The spaces between galaxies are so vast that the probability of stars colliding with each other is almost zero. In fact, the average distance between stars in the two galaxies is so great that most stars will pass by each other during the collision. This can be thought of as a ghost collision in a sense. As galaxies pass through each other, individual stars rarely interact. Scientists use various methods to study galactic collisions. They can capture different stages of collisions by observing distant galaxies. They also create simulations of these collisions using supercomputers. These simulations compress a process that takes billions of years into a few minutes, providing us with incredible visuals. These simulations are not only visually impressive, but also help us understand the evolution of galaxies and how large-scale cosmic structures form. In recent years, we've gained much more information about galactic collisions thanks to advanced observational tools like the Hubble Space Telescope and the James Webb Space Telescope. These telescopes capture stunning images of colliding galaxies in the depths of the universe and provide scientists with unprecedented details. For example, the colliding galaxy pair known as the Mice galaxies, captured by Hubble, is one of the best examples showing the dramatic effects of galactic interaction. Galactic collisions are not just destructive events. They also play a critical role in the evolution of the universe. New galaxies formed as a result of these collisions have larger and more complex structures. For example, the large elliptical galaxies we see today probably formed as a result of the collision and merger of many spiral galaxies. This process is known as hierarchical galaxy formation and is one of the cornerstones of modern cosmology. These cosmic collisions also contribute to the chemical evolution of the universe. New stars formed during collisions produce heavy elements and spread them into space. These elements are later used in the formation of new star systems and even planets. So, elements like carbon, oxygen, and iron in our bodies could be products of galactic collisions that occurred billions of years ago. In this sense, we are truly stardust. Studying galactic collisions provides us with valuable information about the dynamic and ever-changing nature of the universe. This research opens new horizons in fields such as cosmology, astrophysics, and even the origin of life. For example, how galactic collisions affect the formation of habitable planets is an important research topic in astrobiology. In the future, with more advanced telescopes and tools, we'll be able to observe and understand these cosmic events in more detail. In conclusion, galactic collisions, which we call the deadly dance of stars, are among the most impressive and transformative events in the universe. These collisions are like a cosmic ballet, where destruction and creation, chaos and order, death and new life intertwine. The fate of billions of stars is shaped in this dance, and the story of the universe is rewritten. Each galactic collision represents a page in our cosmic history and provides us with clues about the infinite diversity and beauty of the universe. In the future, our distant descendants who will observe the collision of the Milky Way and Andromeda will witness a spectacular show in the sky. This event will provide humanity with a profound perspective on the immense scale of the universe and the transience of our own existence. Perhaps by then, as an intergalactic civilization, we will be not just spectators, but active participants in this cosmic dance. Galactic collisions remind us of the infinite beauty and complexity of the universe. As we study these cosmic events, we better understand our place and role in the universe. Who knows? Maybe one day we'll completely unravel the secrets of this deadly dance of stars and illuminate one of the greatest mysteries of the universe.